All right, so this is where I think calculus gets really interesting. Kind of explain this is this little paragraph here is just basically you have this function here, and I would read through all of this afterwards as well. But you have this function, and let's say we're going to just spin this function, which is right now just a line, and we're going to spin it around, let's say, the x-axis. Well, what you would have is a bunch of circular disks, and here's an example of one disk with a width of delta x. Now, again, eventually this width should be infinitely thin, but for now, let's just think of it as having some thickness. We'd spin it around and we'd get this disk. Well, that disk, well, if we had, infinite disks in here, we could add up the area of all those disks, and we could get the volume. And that's essentially what we're going to try and do here. We're going to find the area of one circular disk, which of course is pi r squared. So the only difference is here, our radius is actually the height of the function, right? It's f of x. So, and this time our radius, you could think of it as y because it's a height. But later we're going to talk about things being revolved around the y-axis, and then your radius would be the x value. So you'd have to get x all by itself and think about how you could define that radius. So that's the main idea here, right? We take the area of this one circle, and then we're going to add up all of those circles from A to B. We're going to add up infinite circles, and the integral lets us do that. So let me show you an example of this. Here we have the function x squared, and we're going to revolve it around the x-axis on the interval 0 to 2. So from 0 to 2, we're just going to spin this thing around. It's going to create kind of it's not exactly a cone, more like a funnel-shaped object. And I'm going to do my best to kind of describe what this thing would look like. So here's 2, so it looks like it'll probably go right about there. And I apologize for my bad artistry ahead of time, but it's going to look something like this, right? It's going to keep spinning around. And over here it would do the same thing, right? It would make some type of weird shape like so, right? Probably not as wide as I made it here, but hopefully you get the idea of what's going on here. You got this weird funnel type looking, cone type looking shape. Well, we can actually we could calculate the volume of this odd shape because, like we said before, we could think of just taking the area of one circular slice here, and I'm just going somewhere in the middle to think about that. But there's this circular slice in here that we can take we could find the area of. And then we could actually find the area of all the circular slices from 0 to 2, and we could add it all up, and that's what the integral lets us do. So here we go. I've laid this out in some steps to help you kind of break this down for you. First thing I like to do is sketch a graph like I did. It just helps you visualize exactly what you're trying to calculate here. And this time they did say around the x-axis. You want to be careful. Sometimes they're going to talk around the y-axis. But this just helps me visualize it. Not necessary for everyone, but you may need to do that, especially if they give you more than one function, and you need to find where where the functions intersect. That's how you're going to define your boundaries. So this one, they told us from 0 to 2, but sometimes they won't give you the boundaries, and they're just going to tell you, these two functions intersect. So find the area in between those curves. And we'll do some problems like that, but you won't always be given these boundaries. All right, now it says come up with an equation that would represent the area of one circular cross-section, or disk, that's kind of what this is, in terms of x or y. Now this is important here, in terms of x or y. Now, whatever, basically, you want your integral in terms, and this I would definitely write this down and memorize this, in terms of the axis, or I'm going to just do parallel lines here, parallel axis you are rotating around. Now, I say axis or parallel axis because right now we're rotating across or around the x-axis, but we could easily rotate around the line y equals 4. And that's parallel to the x-axis, so therefore you're going to be in terms of x. In the same way, if we were rotating around maybe maybe we were rotating around this line, x equals 2. We could do that too. Well, that line is parallel to the y-axis, therefore you would want everything in terms of y. So this is an example of a problem where everything's in terms of x because we're rotating around the x-axis, but on the next problem you're going to see one where we're rotating around the y-axis, so everything's going to be in terms of y. So we've come up with, we need to first come up with the area formula for this circle. And again, the area of a circle is just pi r squared. Well, the radius in this situation, if you think about it, the radius is the height of the circle, and the height of the circle is the function height. So that's why I put f of x there for the radius. And then you could replace that with the actual function itself, which is x squared. And so we find out that this equation, pi x to the fourth, represents the area of this circle. So pi x to the fourth is what we're going to integrate. So then we go down to calculate its volume. See, once we have an equation for the area of any circular cross-section, now we can integrate that, and we're going to add up all the volumes, or I should say all the areas of those circles to get our volume from 0 to 2. And so it would be 0 to 2 pi x to the fourth. The pi can just come outside. And so now you're going to integrate x to the fourth. X to the fourth is x to the fifth divided by 5 with a pi outside. And that's evaluated 2 to 0. The 0 in this situation doesn't matter, right? You would just get 0 over 5. So it's just pi times 2 to the fifth over 5. And that's where we get 32 pi fifths is the volume of this weird solid that we create when we rotate this curve around the x-axis. So, pretty interesting stuff. I'll show you some more interesting problems on the next video. See you guys on the next part.